Okay, we're still in 6.1. This is the fourth video, and as I mentioned earlier, almost everything that we do with exponents, there's a shortcut. And there are two things, however, that are going to be kind of different for you, and that's what we're going to be talking about in this video. So I call this just special notation, and it's two things that you just have to memorize, because you won't be able to figure it out by just taking a look at exponents and what they mean. Okay, let's get started. We have seen exponents, 3 to the 5th. We know what that means. We know that means 3. Whoa, let's get rid of that. 3 to the 5th just means 3 times 3 times 3 times 3 times 3. We know what that means. That exponent's just an instruction telling us how many times to multiply 3 times itself. X to the 10th, x, 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 x. Oh, why did I choose such a big exponent? 5, 6, 7, 8, 9, 10. X multiplied times itself 10 times. So we know what to do when we have just nice, whole, positive numbers. Okay, what we're going to take a look at in this first part is, what about when we have 3 to the 0 power? How do you take 3 times itself 0 times? How do you take x times itself 0 times? How do you take anything to the 0 power? Okay, so when I ask students to guess what all of these answers are, their answer, what they usually guess is probably what I would guess. They guess 0, 0, 0. Surprise! It's not 0. So the first thing I want you to notice is I'm taking a whole video to talk about this because the answer is not what you expect. So just remember, when you have 0 as an exponent, it's not what you're thinking it might be. It's not 0. So let me put a big, it's not 0, it's not 0, it's not 0. So let me erase that and say, well, what is it? So let's do a little bit of discovery. We are going to figure out what we think 3 to the 0 is. Math, you know what math is? Students think a lot of times that math is just formulas and rules and things to memorize, and oh, it just breaks my heart when I hear that. What I think mathematics is just patterns and relationships, and what governs those patterns and relationships. So I love looking at patterns. So what I've done here is I've set up a pattern. I've got the base of 3 every time, and then I've got the exponents. I go from 4 to 3 to 2 to 1 because I'm really interested in continuing that pattern, and so that would be a 0. See if I can see a pattern over here on the right to figure out what, let's put a little question mark there, what 3 to the 0 is. Okay, so let's do our little mathematical discovery here. 3 to the 4, 3 times 3 times 3 times 3. If we multiply that out, we would get 81. 3 cubed, when we multiply that out, we would get 27. 3 squared, and 3 to the 1st. Okay, good so far. So we have to look, we've established a pattern with our exponents. They are decreasing by 1 every time, so we've got a very consistent pattern there. So what we're doing is we're crossing our fingers and hoping that we can find a similar pattern over here on the right. So is there anything that we can do to go from 81 to 27 and do the same thing to go from 27 to 9 and do the same thing to go from 9 to 3? If we can find the same thing in each case, then we can figure out what to do to 3 to get our answer here and replace that question mark with a number. Okay, so maybe it's easier to see. Let's start with 9 and 3. How can you get from 9 to 3? Well, you can divide 9 by 3 and you get 3. You can divide 27 by 3 and get 9. And 81 divided by 3 gives us 27. So I'm going, yahoo! I see the pattern. To go down this way, we can go get the next number in the list by dividing each of the previous one by 3. I think we're ready. What then is 3 divided by 3? The answer is 1. So right now I'm strongly suspicious that 3 to the 0 equals 1. And just to make a long story short, I'm just going to say, and it does. And this is one justification why 3 to the 0 equals 1. Okay, so let's put that rule down. And that's one thing that I'm going to call a rule, because there's no way we can figure that out on our own other than just looking at that pattern. So I have included the word not just memorize, but accept it. Sometimes it's very difficult for students to accept that when you take anything, and I'm letting anything be indicated by an A here, and raise it to the 0 power, what you get is not 0, what we expected, but 1. Okay, now I've got a caveat to make here. A can be anything except 0. So a lot of times you will see, mathematically speaking, another way to say A is anything but 0. You might see A not equal to 0. That doesn't affect what you're doing. It just means we want to be real clear, and we do not want to tell any lies. Anything to the 0 except 0 is equal to 1. So in other words, if you had 0 to the 0, it does not equal 1, and in fact 0 to the 0, oh, there's undefined again. So we just don't even bother worrying about 0 to the 0. Okay, we've got to take a look at a couple examples because I've got some cautions for you. Remember, let's get down there, that last page. Do you remember one of the things that I asked you to remember about? I can't get down there. Okay, let me just start writing here. Do you remember what I told you before? Important thing to remember. One of the most important questions when you're dealing with exponents is, what does that exponent apply to? So let me take a look. Let me just squeeze this in down here. If I have 5x all to the 0, do you recognize that it doesn't matter what we have inside that parentheses? Well, let me go back up a little bit. So I go, okay, we've got an exponent of 0. The question is, what does that exponent apply to? Those parentheses indicate that it applies to everything in here. So that's anything. 5x is anything, so the answer is 1. Okay? And if I had 5x squared y cubed z to the 7th w 24, it doesn't matter what you have inside that parentheses. If you take it to the 0 power, the answer is 1. So as long as you don't have 0 in there, and I promise you I'll never do that to you, you basically don't even care what's inside there, because as soon as you see that it's raised to the 0 power, it's going to be equal to 1. Okay, let's get back up to, well, I'm having a little bit of issue with my paper here. I'm getting there. Okay, now this is where we got to be careful. So we saw, let me make this a little bit cleaner. We saw that 5x quantity to the 0 equals 1. What is 5x to the 0 equal to? Oh, students see that 0 as a exponent. They go, oh, it's equal to 1. It's not equal to 1, because who does that 0 exponent apply to? That 0 only applies, it's very exclusive, it only applies to the x. So what we've got here is 5 times x to the 0, and we can replace that x to the 0 with 1. So essentially what we have is 5 times 1, which is equal to 5. Another example. Let's make it negative 5x to the 0. Oh, thank you, teacher. Aren't you happy to see that 0 applying to everything that's inside that parentheses? So it doesn't, just like before, it doesn't even matter what's inside here. When you see that that 0 applies to everything there, then your answer is 1. But what if we have negative 5x to the 0? Answer? Negative 5. Because again, that x to the 0, that 0 is the only that 0 only applies to the x, so that's only the part that equals 1. Okay, one more before we leave this. Let's make it negative 5 to the 0. What's your answer? The question is always, who does that exponent apply to? The exponent only applies to the 5, so I'm going to put a circle around it and say that I've circled equals 1. That little negative is outside, so he doesn't get the 0 exponent treatment, so you've got negative 1. Okay, let's continue in the next video to discover the second thing that we've got to just accept and memorize. I'll see you there.